Bismillahirrahmanirrahim. Assalamualaikum, and today I want to present about my individual assignment, which is fast log analyzer using parallel computing to detect security threats. First of all, I will present about the problem statement. In modern cybersecurity, speed equals to survival. Process 15 million lines of logs using traditional single core method is a bottleneck that leaves system vulnerable. So what I did is I designed the fast log analyzer, which is a high performance engine that utilizes parallel computing to check through massive dataset such as 15 million lines of code or 100,000 lines of log. By distributing the workload across all available CPU threads, it transforms an ordinary laptop into a forensic powerhouse, detecting over 1.2 million threads in a fraction of the time. So the first problem statement is the challenge. Modern servers generate gigabytes of logs daily, especially in large company that has a lot of staff. It needs AAA, authorization, accounting, and also authentication. And also the second problem statement is the impact. If an attack happens at 12 p.m. but the analyzer takes 10 minutes to find it, the damage is already done. So first, I want to talk about the methodology. So I use the divide and conquer approach, which is the divide and conquer approach is a problem solving technique that involves breaking complex problem into smaller, more manageable sub-problem. So what I did is I generated the data locally, split it into 8 parallel tasks using multiprocessing, search for threads using regex patterns, and then combine the result into a final forensic report using matplotlib for analytics. So for matplotlib, it generates the graph when we run the Python file. And regex is a pattern matching engine. It's the fastest way to turn a giant pile of messy text or logs into organized data that can be known as the security threats that we have, such as SQL injection and more. So now we will go to the performance comparison. As we can see, when we run the 15 million lines of logs, for sequential 1 core, it takes 36.14 seconds, and also for the parallel 8 cores takes 11.34 seconds. As we can see on the right side, we can also see the concurrency. Threaded IO to read 15 million server forensic log and completed in 2.8792 seconds. And the speed up factor for both sequential time and parallel time is 3.19 faster. Okay, next for the 100,000 lines of logs. For sequential, it takes around 0.30 seconds, and for parallel, it takes 0.11 seconds, and also for concurrent, it takes 0.0306 seconds. And the speed up factor for both parallel and sequential is 2.58 faster for parallel than sequential. So it is mind-blowing that when we have millions or 1,000 lines of logs, it takes only about 11 seconds or 12 seconds approximately to give a report for us, to tell about the threats that we get, such as SQL injection, brute force, SSS attack, unauthorized MASS and others, and also the total threat detected and the total normal login. So it is very efficient for us, especially for network engineers, to see what happened in the server. So now I will go to the challenges and solution. First solution is I use the chunky logic. Instead of letting Python decide how to handle the data, I manually slice the data into 8 chunks specifically tuned to my CPU core count. And also second, I pre-compile the regex using re.compile function. This doesn't just make it faster, it ensures the pattern is validated once and applied consistently across all 15 million lines. So now we will go to the demo. So So now I'm in my coding directory, which is the ITT440 underscore log analyzer. Now what I want to do is to do the demonstration, and for the demo I will use the 15 million logs. So first what we have to do is we have to activate the VNV. VNV is Python module for virtual environment, and what command that we can type is this: source space VNV /bin /activate to activate the VNV, and press enter. Okay, now as we can see on the left side of the sentence, we can see a bracket and VNV is there. Now we can run the Python file by using this command python3 and also the name of the file. So if we don't know the name of the file, we can list all of the files in the directory, which is ls. As we can see, there are a lot of files in the directory. We have 100k logs, 50 million logs, the Python file, which is the analyzer, and also the performance result png, which is the graph. When we run the Python file, the matplotlib will generate the graph for us, and also the VNV directory. Okay, now we will run the Python file by using this command python3, and the name of the file, but for me, is the analyzer.py, and press enter. As we can see, first line it checks for the log file. For me, is the 50 million server forensic log. It exists. Then it will start run the concurrency, sequential, and parallel. It takes a time, including like the process, especially for the sequential, it takes a lot of time. As you can see, it auto generates the detailed forensic analysis report. It tells how much SQL injection, how much brute force, and so on, and the total threads, the total normal logins, and also the total line process. So as we can see, for the sequential, it takes 49.29 seconds, parallel time takes 15.35 seconds, and also speed up factor is 3.21 faster parallel than sequential. And also, as we can see at the top, concurrency completed in 3.9244 seconds. Okay, now we will go to the 100,000 line of code, but I will edit the file first using this command vim analyzer. Vim is a text editor, so we can use nano or vim or any text editor that you want, and press enter. So we will change here 100k server log and 100,000. Okay, then save and quit, and let's run the program again. python3 analyzer.py, and press enter. As you can see, it is a lot faster because it only have 100,000 line of code approximately, so it runs around 0 to 1 seconds approximately. And for such as for concurrent, it takes 0.0486 seconds, sequential 0.41 seconds, and parallel it takes 0.13 seconds, because the total line is not as much as 50 million lines. So the more lines of code that we have, the longer time it will take to process the line of code. So as we can see at the bottom, the performance graph saved as performance underscore result.png. So as we can see, this is the graph that it generates for 100,000 lines of code. This is the same for 50 million lines. If we edit the code like before, for the file that we want to execute and also the data size, And as we can see, the sequential takes 0.41 seconds and parallel takes 0.13 seconds. Thank you for your time and attention. I appreciate your interest in learning more about the profound impact computers have on modern society and the exciting technological advancement yet to come. Thank you and Assalamualaikum.